Okay, so today we're going to be talking about atomic orbitals. So atomic orbitals are all defined by quantum numbers. And there are 4 different quantum numbers that we're talking about. And ironically, the quantum numbers are all letters, but they have numbers associated with them. So the 4 different factors are energy level, which is N. And energy levels range from 1 to 7, and they describe the approximate distance from the nucleus. They have a maximum capacity for electrons of 2n to the second. And then we have sublevel, or L. And sublevel describes the type of orbital that we're talking about, either SPD or F, and ranges from 0 to n-1, although technically there are only 4 options, so it's really 0, 1, 2, or 3. They describe the shape of the orbital. Angular momentum, or m sub L, which ranges from negative L to L, and that describes the location of the electron in the orbital, or more in the sublevel. And then spin, which isn't actually spin, it's just, that's the word that we use to describe it, but it's m sub S, and that is either a half or negative a half. And it describes the spin, either spin up or spin down, of the electron in its orbital. And again, this isn't really the spin, it's just kind of a way that we have used to describe it. So you've got energy level, sublevel, angular momentum, or spin. Now the sublevel, SPD or F, contains different orbitals within that sublevel. And that's what kind of angular momentum starts describing, is which electron, or which orbital the electron is going to be in. Now, electrons are like snowflakes in that no 2 electrons can have the same 4 quantum numbers. So you can't have identical electrons. You could have the same 3 quantum numbers, but the 4th one would have to be different. So you could have the same N, L, and M sub L, but your M sub S would have to be different. Or you could have the same L, M sub L, and M sub S, but your N would have to be different. So you can have 3 of the 4 be the same, but the 4th one has to be different. And that's because no 2 electrons are the same. And each of these quantum numbers is describing a different electron. So let's talk about energy level. Energy level is N. It can be found by looking at the periodic table. The row the element is found in is the highest energy level, or N value, for the quantum number. So, for example, lithium, while it's in the 2nd row, so it has an N value of 2, it had to go through the 1st row in order to get there. So it has N values of 1 and 2. And this will make more sense in a minute. Potassium is found in the 4th row, and it has an N value of 4, but it would have had to go through N, 1, 2, and 3 to get there, so it has all of those as well. So let's talk about sublevels. Sublevel is related directly to the energy level and describes the shape of the orbitals, or the shape of the sublevel. The sublevel options are from 0 to 3, and the value of the energy level describes how many sublevels there are, 0 to n-1, corresponding with SPD and F. So what does that mean? L equals 0 is an S orbital, L equals 1 is a P orbital, L equals 2 is a D, and L equals 3 is an F. So for example, lithium is N equals 2, so it has 2 sublevels, 0 and 1, meaning it has electrons has the potential for electrons in the S and P orbital. Potassium has N equals 4, so it has 4 potential sublevels, 0, 1, 2, and 3, or SPD and F orbitals. Now, that's just the potential at that energy level. So, sublevel shapes, SPD and F, let's think about what that is. Now, I don't expect you to memorize this at all. This is just kind of to describe it and let you guys think about it in kind of terms that you could see. So an S orbital is just this circle, so there could be electrons in that circle somewhere. A P has very kind of more designated locations, so there could be an electron here, or here, or here, or here, or here, or here. And F gets really, really complicated. So you can see, as you get to these more complex sublevels, the locations start getting mapped out as more and more discrete locations for all these electrons. But they get, so like the space that they could be gets smaller and smaller, but there are more and more options. And again, remember that L is equal to 0 is an S orbital, L equal to 1 is a P, L equal to 2 is D, and L equal to 3 is an F. So let's talk about angular momentum, or m sub L, which describes the location of electron within the sublevel, or which orbital it belongs in. So it varies between negative L and L. And for any L, there are 2L plus 1 orbitals in that sublevel. So what does that mean? So for example, Li has an L value of 0 and 1, S and P. So m sub L has a range of 0 for the 0, because there is no negative 0 to 0, so it's just 0, which is 1 orbital. Or in the p orbital, which has L equals 1, it has 2L plus 1, which is 3 orbitals, or negative L, 0, and 1, which is 3 orbitals. So lead has an L of 0, 1, 2, or 3, so an SPD or an F. So for the S, the m sub L range is 0, which is 1 orbital. For L equals 2, it has, for L equals 1, it has 3 orbitals, which is the p orbital, negative 1, 0, and 1. For L equals 2, it's negative 2, negative 1, 0, 1, or 2, which is 5 orbitals. Or L equals 3, which is the F, which is negative 3, negative 2, negative 1, 0, 1, 2, or 3, which is 7 orbitals. And so this should make sense, as there is only 1 orbital for the S sublevel, 3 orbitals for P, 5 for D, and 7 for F. And we'll get into that in a second, looking at the orbitals, because that is really, really complicated. So let's take a longer look at it. So if L is 0 and m sub L is then negative L to L, then the range would be 0, because there is no negative 0, there is to 0. That doesn't exist. It's just 0. So the S sublevel has 1 orbital, okay, 1 little slot. If L equals 1, m sub L is negative L to L, then the n sub L range would be negative 1, 0, or 1. P sublevel would have 3 orbitals, negative 1, 0, and 1. You can then see that if L is 2, your range is going to be negative 2, negative 1, 0, 1, and 2, or the D sublevel has 5 orbitals, negative 2, negative 1, 0, 1, and 2. And then if L is 3, you've got negative 3, negative 2, negative 1, 0, 1, 2, or 3, 7 potential orbitals. Now each of these orbitals can contain 2 electrons. So these are what you can think of as those locations on that table with the little diagrams for each of the individual electrons. So these are all different locations for those electrons to fit in. And you can fit 2 electrons in each orbital, and that's going to get into our m sub s. But I could fit 2 electrons here, and 2 electrons here, 2 here, and 2 here. So let's talk about spin. Spin of the electron describes the magnetic properties of the electron. There are 2 directions of spin for an electron, up or down, which that is why, because there's spin up and spin down, that's why you have the potential for 2 electrons in each orbital, because you can have the potential for 2 different electrons. That means that the 4 quantum numbers wouldn't be the same, because the m sub s would be different. So let's take an example. Neon has 10 electrons. N is going to be equal to 2, because it's in the second row. The L is going to be 0 and 1. So it has an S and a P orbital. M sub L is going to be from negative 1, 0, and 1, or just 0. And then m sub s is going to be plus a half or minus a half. So you're going to have 2 electrons in the 1s, 2 in the 2s, and then in your 2p, you're going to have the remaining 6. 1, 2, 3, 4, 5, 6. So there's a total of 10 electrons. Now each of those electrons can be described by its own 4 quantum numbers. So those 10 electrons are right here. I've got the n sub 1, 0L, 0m sub L, plus a half. That would be this electron, or this electron, however you want to think about it. This n equals 1 is L of 0, m sub L of 0, negative 2, that would be this electron. N equals 2, L of 0, that's a 2s orbital, plus a half, that's that electron. 2L of 0, so s orbital, with a negative a half, that's going to be this electron. And then we get into the 2p. 2p, so 2 and then L equals 1, and you've got negative 1, so that could be this orbital, and I've got a plus a half, so that's that electron. Negative a half, this electron. 2p and the 0 would be in this here, plus a half, negative a half, plus a half, negative a half. 2p1 would be plus a half, negative a half. So you can see that we can describe each of these electrons. by 4 different quantum numbers. And the total number of electrons is always going to be whatever we said it was 2. So the total in that row is going to be, or total in the n value is 2n squared. So here we had an n of 2, which means we have an n of 2 and an n of 1. So 2 times 2 squared plus 2 times 2 squared. So we've got 2 times 2 is, 2 squared is 4 times 2 is 8. 1 squared is 1 times 2 is 2. So 8 plus 2 is 10 electrons. So you've got the whole 10 electrons. Okay. Now, we can describe and name the following quantum numbers. So if we had n of 4, L of 0, m sub L of 0, and an m sub s of plus a half and minus half, that would mean that we're talking about the 4th energy level. L is 0, so we're talking about an s orbital. And we're talking about the s orbital because it's n sub L of 0. And it could be plus a half or minus a half. So it's a 4s, which is the s orbital. It's an electron in the 4s energy level, which is an s orbital at the 4th energy level with 2 possible electron spins, spin up or spin down. If n is 3, L is 2, m sub L is negative 2, negative 1, 0, 1, or 2, m sub s is plus a half or minus a half, we're talking about a 3d orbital, because it's L equals 2, with a d sublevel in the 3rd energy level with 5 possible d orbitals, each with 2 potential electron spins. Okay? Or we could give values for different orbitals. If a 3p, that's going to have an n of 3, an L of 1, and an m sub L ranging from negative 1, 0, and 1, and 2 m sub s values, plus a half and negative a half. Or a 5f, n is equal to 5, L is equal to 3, m sub L could be negative 3, negative 2, negative 1, 0, 1, 2, or 3, and then m sub s of plus a half and minus a half. Okay? So, atomic orbitals are kind of hard, but we're going to get through it. It's a lot of just thinking about and learning about what am I talking about, how am I getting through this, what energy level am I at, what kind of orbital am I talking about, and what's going on with my electron. So we'll have some practice with this, and then it's going to apply a lot to what we're getting into next, which is electron configuration. So, see you guys later.